In this problem, it's a geometry problem. And they give you a diagram because I guess the AMC 8 is like pretty nice. They give you a lot of they give you a lot of diagrams. But just know that like if they don't give you a diagram, just draw a diagram if it's a geometry problem. So a square has side length 2 and a circle share. Okay, a square with side length 2 and a circle share the same center. So the total area of the regions that are inside the circle and outside the square is equal to the total area of the regions that are outside the circle and inside the square. We want to know what is the radius of the circle. So the idea for this problem is like they both share the same center, right? So they both have this point here as a center. So they say the total area of the regions that are inside the circle but outside the square. So what is that region, right? So regions that are inside the circle but outside the square. So that represents like these red regions, these like kind of like weird, I don't know what they're called, weird like regions, right? So like they're colored in red here. Like those are the regions that are inside the circle, but they're outside the square. And we're given that equals that the sum of the areas is equal to the total area of the regions that are outside the circle and inside the square. So outside the circle is like this region, or like inside the square, right? Is like this total region, but it needs to be outside the circle. So that represents like this total region here. These like kind of corner, these like corner regions here. And we're essentially given that like the sum of the blue regions is equal to the sum of the red regions. And we want to know what is the radius of the circle. So the idea for this problem is like, it's kind of really tricky, right? These red regions and these blue regions are not like regions we know how to calculate. They're not like squares where we can, or circles or rectangles or triangles where we have a formula that we can use to calculate. Like these are like irregular shapes that we don't really have a formula for. But the key observation for this problem is that like, notice that the circle and the square, they both kind of share this like, they both like, let's color in this green region, right? This green region is like this weird, this region inside like the thing, right? So here, so this is like the green region. So notice how like the circle, right? So I can say the circle, the area of the circle, I can say it's the red plus the green, right? So like that's perfectly legal. That's perfectly reasonable. The circle is the sum of the areas of the red region and the green region. I can say that. And then for the square, I can say the square is equal to the sum of the blue regions plus the green region, right? This is also perfectly reasonable. Like the circle is the area of the red spots plus the area of the green spot, and the square is equal to the area of the blue spots plus the area of the green spot. So we can kind of have like these weird equations, right? So circle equals red plus green, square equals blue plus green. And we're given that the total area of the regions that are inside the circle and outside the square, so that's the red region, is equal to the total area of the regions that are outside the circle and inside the square. So that represents the blue region. So remember the question gave us that the red region, the area of the red region is equal to the area of the blue region. And the reason that's helpful is because now, if these, clearly they both share a green, and now if the red and blues are equal, that tells us that the area of the circle and the area of the square must also be equal. And that's a lot easier to deal with because we know how to find the areas of circles and we know how to find the areas of squares. We know that the square has side length 2, which is given in the problem. So that tells us that the area of the square is 4. And we want to know what is the radius of the circle. And the area of the circle is just pi r squared, where r is the radius. So if we were to solve, we get r squared is 4 over pi. So r is equal to 2 divided by the square root of pi. So that would give us choice A, and we would be done.